Okay, so in this problem, let's draw our free body diagram again. Our first step, as usual. So I'll draw a line for the top part of the structure, and then a line for the column part of the structure. And I'll assume directions for the reactions at A. So I'll assume up for AY. I'll assume to the right positive for AX. And my right-hand rule, I'll assume the moment at A is in that direction. Okay? Now out here at C, I have an applied force of 5 kips. And I've got this distributed force. How am I going to manage that? Well, we'll probably want to do the concentrated equivalent force. So what's the area of the curve? It's 0.6 kips per foot times how many feet? 15. So that's 9 kips. And where's that 9 kip force going to act along this bar? Right in the center, right? So there's my concentrated equivalent 9 kip force, and halfway will be 7.5 feet. I'm going to go ahead and put my dimensions here. So what would this, let me see, this is 3 feet. So that would be 4.5 feet. Do I have all the pieces right? Okay, so in our strategy that I proposed earlier about taking your time and drawing a good free body diagram, I think this will be acceptable. We have everything we need. So now we should just proceed. So what should I do first? Well, I'll just play it the worst possible case. What if I sum forces in the x direction? Can I solve for that equation? I think I can. I'd have AX and 5, so I could solve for AX that way. What about summing forces in the y? Can I do that? I think so. What about summing moments about A? Yes. So this one doesn't really have much of a strategy. Any way you go will work out. But I'm a creature of habit, so I'm going to sum moments first. So there's my positive moment, right-hand rule. And I'm going to sum my moments about A. Make sure they're in equilibrium. So let's go through and find all the moments. So what's the moment about A due to the 9 kip? Is it positive or negative? Negative. So the force is 9 kips. And the moment arm from this line is this distance, 4.5 feet. What about the moment about A for this 5 kip force? Also negative. And what's its moment arm? 10. So I've accounted for the 2 forces. What have I not accounted for? Do AX and AY create moment about A? No. So what's left? The moment at A itself. So I should be able to solve for that in terms of the moment at A. I don't know what that is. 36. I don't know. Somebody help me with that. 41. 91.5, I'm guessing.
I got 90.5.
What'd you get?
I got 90.5.
Oh, I'm only off by a little bit. Somebody else help me. This is 50. This is
36.
30, 40.5. Yeah, 90.5. That sound good? And it comes out to be
90.5.
Yeah, 90.5, and that'll be kip feet. And it came out positive, so that means I assumed the right direction for the moment. The moment is actually counterclockwise. Okay? Any questions about that? So now I'll just, again, habit. More often than not, in these kinds of problems, you'll sum forces in the y next, just because it'll get you the more information. So I'll do that. So I've got AY, it's acting up. What else is in the y direction? 9. That's it, right? I think I can solve that problem. AY is equal to 9. And it came out positive. So again, I assume the right direction. And then finally, assuming to the right is positive, I will sum forces in the x direction. And what do I get? Well, I have AX acting to the right, so that's positive. What else do I have?
5K.
Up 5K, also positive. So solving for AX, you simply find that it's 5 kips, and the minus sign just means it's opposite of what you thought. It's actually acting to the left. Any questions about that one? It's kind of like statics all over again, right?